the physics for module 2. Hi everyone, so today I'm going to present to you computer tomography physics. Now I hope this to be very comprehensive, thus I'm going to have the next subjects. So window settings, acquisition parameters, image quality, and from those image qualities aspects we will look at crust being contrast and contrast resolution, R spatial resolution, A artifacts, S signal to noise ratio, and T temporal resolution. So household units are the key to understanding computer tomography. Computer imaging works by detecting how different tissue in the body attenuates or weakens the X-ray beam. This attenuation varies because tissue have different atomic bonds and densities. Denser tissue have a stronger atomic bond, so attenuate the X-ray more, making them appear lighter on the CT scan. Less denser tissues attenuate X-ray less, making them appear darker. Well, you see, the machine can recognize about 2000 shades of gray. It represents a wider range of tissues. However, if we need to focus on just the center tissue type, there are too many shades of gray and our eyes cannot distinguish between smaller the differences in grays that computer might. So by adjusting the window level and window width, we can control that and highlight specific areas that are of interest. This is gonna help us in just focusing on the details that we want to see. Now window width is mostly about the numbers of grays that we are looking at, and window level, it's basically the main point of grays that we are interested in, the main type of tissue that we are interested in. And right here you will see an image of types of grays and their representative tissue. So bone would be much higher when it comes to the shade, much lighter, and lungs would be much darker. In between we have tissues like fats, water, and so on. So the next subjects I would like to talk on are MS, KVP, tube current, slides thickness, rotation time, field of view, and in the end pitch. So MAS is basically the current that passes through the cathode into the anode, where it meets with the atoms of tungsten, and that will change the path of the electron, and that will result in a photon of X-ray. So now it's the amount of current that goes from the cathode to the anode per second. So this is MAS. KV, tube voltage, it can be seen either as the power or the speed of that current. As higher the energy, it has more potential to emit higher level photons. Okay. So let's talk about tube current. Well, any charge that is moving will have a magnetic field. To take care of that, there are a couple of things put in place into a X-ray tube, like magnet focusing devices and magnet shielding. Another thing is that it has to be in the vacuum. The current has to be in a vacuum, otherwise there will be friction. The electrons would friction with the air and there will be no acceleration, so therefore no photon emission. Let's talk about slide thickness. The slide thickness is the individual thickness of the slices captured during the CT scan. Thinner slices provide a higher spatial resolution, but require more slices and increasing the potential of higher radiation dose. That is the full rotation time that it takes for the CT scanner to complete one full rotation around the patient. Short rotation times can reduce the motion artifacts that might come from the patient moving and its organs by normal bodily functions. Short rotation are therefore better for that. They request a rapid data acquisition and processing. Field of view, it's basically the area that we wish to scan. It's usually you would want, for instance, if you have a thicker patient, you would want a smaller field of view because of the scatter radiation. So what happens is, again, there is a lot of tissue there, and the X-ray wants to pass through, but it can't because it just hits a lot of fat and tissues, and the result is in scatter radiation. Pitch is the ratio of the distance of the CT table moving one rotation of the X-ray tube to the thickness of slices being scanned. So if the table moves a distance equal to the slice thickness per rotation, the pitch is 1. If a higher pitch means that the table moves forward per rotation, scanning a larger area quicker, but potentially reducing image quality. These parameters are very crucial to understand the physics of CT